So with this, I decided to with this screencast, I decided to go to Jupiter, and I found this really long video that goes through the details of Jupiter and all its history, well, some of its history as well as some of its moons. Um, well, here it is talking about how it's with its massive gravity well that it's absorbed a lot of debris that could be hitting us on our planet on Earth. And then it also talks about rings. Yes, Jupiter does have rings. A lot of people didn't know that. They were first discovered in the 70s with the Voyager program. It's very hard to see them, but they originally, when they were taken, the pictures were taken of them. They thought they broke the camera, so that's a very funny story for that. They thought they had a broken camera on a machine that was well beyond their reach to fix. But it turned out that it was the first picture ever taken of Jupiter's rings, which is a very big deal for us here. And then we're going to be coming up on the big red spot here. So the big red spot is the massive storm that we're all very familiar with. The Great Red Spot, obviously, is one of the oldest storms that we know of in the solar system to date. It's been going for over 300 years here, just talking about it here, and talking about how some of the other storms have been going for 50 years. And a little fun fact about the Great Red Spot is that you could fit several Earths inside of it. So if you could imagine a hurricane that encompasses the entire Earth and then some, you would be imagining the Great Red Spot very well. And then it does talk about here how Jupiter is believed to have a core, a rocky core at least of that, but there is also this other thing that we know as liquid metallic hydrogen, which is a very hard, complex idea to explain to somebody, but essentially the hydrogen gets compressed so much and gets so hot that it is turned into almost a semi-liquid slash solid state that is super hot. But it's not close to the rate of fusion that you'd see in the sun. Here it talks about one of the smaller moons of Jupiter, a very similar moon to those of Mars, very asteroid-like. Like it says, it's a very small, rather insignificant one, but it is very heavily cratered. So it could have been larger, and just over the years have been beat to a pulp by impact after impact. So we don't know the exact history of it, but we do know there have been several large hits to it based on some of the craters that can be seen. And it has a very distinct shape to it. I like to think of it as an arrowhead per se. And here it points out one of the prominent features, Gaia, sorry. Very olive drab color looking, indentation. So it's very noticeable here in this very oddly pictured event. And here it talks about the Atafalca facula. Faculas is just something that's recognizable as a bright spot on the surface of an object that you can see through a telescope like the Hubble telescope. And next we're going to move on to Io, one of the more known moons of Jupiter. Io is a very unique, very how should I say it? Very interesting from a scientific perspective. It's one of the few places in our solar system that you can find active volcanoes. So there is active volcanoes. I believe it talks about that there's over at least 100 active volcanoes on this. So here it does say that besides Earth, this is the only other place in our solar system that you can find active volcanoes. And because of its tenuous atmosphere, the volcanic plumes from all these volcanoes do shoot up very high. Shoot out very far, I should say. Not necessarily high, but 60 miles out from the surface. And then some of that dust would eventually escape, but most of it does collect back down onto the surface. But like it does say, there's more than 100 volcanoes. Some of them are very prominent, very large volcanoes. And here we are going to look at one of these volcanoes. As it is a two-dimensional image laid onto the three-dimensional space, you can't really see the volcanic plume that well, but it is there. It's called Prometheus, not necessarily named after that terrible movie, at least in my opinion, a very terrible movie. But it is a very cool volcano nonetheless. You can see that right here is that volcanic plume. But as it is a two-dimensional image laid onto a three-dimensional object, it is kind of hard to make out. And that's the limitations we have with software nowadays, is that you can't necessarily